Hey, so we have our very last lesson of the year officially here. We're going to be solving radical equations algebraically. We already discussed how to solve radical equations through graphing a couple units ago, but we're going to give you an algebraic technique here, which is primarily the traditional way for solving them. And then what we're going to expect you to do is to be able to compare solving graphically through solving algebraically, and then understanding what an extraneous solution means, and then which method is most appropriate for you. So when we're looking at this first question, we have the square root of x equals 5. If I'm trying to solve the equation for x right now, x is trapped inside of a radical. So it's a square root radical, by the way, so which means we would take it to the reciprocal power, which would be squaring. And whatever you do to the left side, you're going to have to do to the right side, and you end up with x, ooh, that's ugly, equals 25. And these are really easy to check. You take 25, plug it back in for x, and you get the right answer. This next question, I don't want to square anything until I get the radical isolated, so I would start by adding the 2 to the other side of the equation. And then we have the square root of v equals 10, and then now we're going to go ahead and raise both sides to the second power. Square and square root cancel each other out, and you get v equals 100. Again, very easy to plug this in and make sure it works. All right, my next question, the radical is isolated. So I'm going to go ahead and square both sides. But that's not going to be the end of our problem, because within this radical we had a bit of algebra. Sorry if you can hear the bell. Alright, 4 squared is 16, and now we're going to solve this equation. Turns out just to be a couple step linear equation. So we have 3n equals 12, and then dividing both sides by 3, and we're going to get n equals 4. Again, easy to check. Plug it in, make sure it works. This next question, I was trying to get sneaky, and instead of writing the square root symbol, I wrote the 1/2 power. But remember, the 1/2 power is the same thing as the square root, so if you would rather see it as the square root instead of the 1/2 power, that's fine. Either way, you're going to have to raise it to the second power. That's going to cancel with the 1/2 or with the square root. And then you got to do it to both sides of the equation, of course. So we end up with 25 equals 9m minus 2. And then a couple step algebra sentence, add 2. So 27 equals 9m. Then divide both sides by 9. Changed colors on myself. Alright, m equals 3. Again, really easy to check. 9 times 3 is 27 minus 2 is 25. Square root of 25 is 5. Check, done. So if this was on my final exam, hint, 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 I would definitely be checking my answers. This next question is unusual because we have a square root symbol on both sides of the equal sign. And I like the way it's set up. You never want to have 2 square roots together unless you are forced to have 2 square roots on the same side. If they're separated by the equal sign, that's good news for you, because now when you square each side, they're both square rooted, so they end up canceling out, and you get a multi-step linear equation that you get to solve. So let's go ahead and I'm going to add this 2x over here. Since I'm bringing x's to the right, I'm going to go ahead and bring the constants to the left. So my next line says -5 equals x, and that is my solution. Now, I do want to be a little careful. There are things called extraneous solutions. So now that we're getting to more complicated questions, what I'm going to do is I'm going to make sure that if I plug in a -5 for x, that this works out. So like if you plug in a -5 right there, you're going to have the square root of -3, and then -2 times -5 is plus 10, so that's the square root of 7. And then over here, you have the square root of 2, and then minus -5 will be plus 5. So we do get the square root of 7 on both sides of my equal sign. So far so good. This equation, again, we're going to be squaring both sides. Now what's unusual about this problem, not the square rooting of the square, or squaring of the square root, that's not different. Here's what's different. Over here on the other side of the equation, it's not a number, it's a variable squared. So what we end up with is no longer a linear equation to solve, but we have a quadratic that we have to solve. So we have a bunch of methods for solving a quadratic. We have factoring, square rooting, sometimes completing the square, sometimes quadratic formula, always. So I usually try factoring because it's my go-to method, it's my best method. In order to solve a quadratic, for most of those methods, I want it in standard form. So I want like 0 on one side of the equal sign. So I'm going to first rearrange the equation by adding the 30 over and subtracting the 11b over. So over on the other side of the equal sign, I have b squared minus 11b plus 30. And then I'm going to try factoring. So let's see, 3 and 10 won't work, 15 and 2 won't work, 5 and 6, that would work. So if I made them both negatives, how about b minus 5 and b minus 6? Those would multiply to 30, but the factors would still add up to negative 11 on the inside arches. So remember, we're solving this quadratic. So now you have to take your factor, b minus 5, set it equal to 0, and get b equals 5. And then same thing with the b minus 6. If I solve that, I get b equals 6. Now, before I go ahead and say these are my answers, I have to worry about what's called an extraneous solution. So if I plug them in and they don't work, that means I have to consider it extraneous, and I'll show you what that looks like in a second. So if I plug in a 5 right here, I get 55 plus negative 30, so that's square root of 25. The square root of 25 is equal to 5. So 5 checks out fine. That's a good answer. Now let's do the same thing for 6. If I plug in a 6 right here, that's a 66 minus 30. So that's square root of 36, which is 6. So they both check out. This is a case where my formula or my equation produced a quadratic. I got 2 answers from the quadratic and they're both good. Let's try another. This is another unusual case where if I square both sides, the right side of the equation is easy. The square root and the square will just cancel. But over here on the left side, you have v minus 2 times another v minus 2. Remember, v minus 2 squared is a distribution problem. So if I go ahead and FOIL that out, we used to call that v squared minus 2v plus another negative 2v plus another negative 2v, so negative 4v. And then negative 2 times negative 2 is plus 4. So, bad news, we have another quadratic. Double bad news, it's not in standard form, so I first have to rearrange some terms. I'm going to start by subtracting this 4v, and joining it up with that one. I'm also going to add this 11. So, we end up with v squared. This is now a negative 8v, and that's a plus 15, equals 0. Alright, so factoring that guy, got to multiply to 15, add up to negative 8. So how about v minus 5 and v minus 3? My tablet's not working. Okay, so now we're going to take our 2 factors and we're actually going to solve them. So v minus 5 equals 0 would give you v equals 5, and v minus 3 equals 0 would give you v equals 3. Now again, before I commit to these 2 answers and I say they're both good, I have to go back and check to make sure they work. So let's start by plugging in the 5. If I put a 5 right here, I get 5 minus 2, which is a 3. And if I put a 5 right there, I get 20 minus 11 is 9. So I have the square root of 9, which also is 3. So that one works. Circle it. Let's go back and check 3. 3 minus 2 is 1. And then over here, 4 times 3 minus 11 square rooted. Let's see, that's 12 minus 11, so that's 1. So I get 1 equals 1. Check. So they're both good solutions. Another case where I did all the work, I got 2 solutions, and they both work. I really don't like to square both sides of the equation unless the radical is isolated, or if there's more than one radical, that there's just one per side. So the first thing I want to do in this question is I would like to add this n over here. So I'm rearranging a little bit first. Makes my life easier in the long run. So I have 15 minus 2n equals, instead of negative 6 plus n, I'm going to call that n minus 6. And now I'm going to square both sides. And just like on the previous question, when you square this n minus 6, I have to remember that that's like a foiling problem, a binomial times a binomial. It's n minus 6 times another n minus 6. So let me move my screen out of the way, maybe. There we go. I don't know why it draws lines while I do that, but it does. Okay. So we end up with 15 minus 2n on the left side. And then when I FOIL this out, n squared minus 12n, because negative 6n. And then negative 6 times negative 6 is plus 36. So once again, we have a quadratic. I need to subtract this 15 over here. I'm also going to have to add this 2n over here. because I need standard form in order to factor or complete the square or use quadratic formula. So n squared minus 10n plus 21. So when I go through the effort of actually factoring this, well, in fact, it's pretty nice. And spoiler alert, every one of these that I'm going to give you in this lesson are going to factor real nice. We get n minus 7 times n minus 3 for my factors. So for now, I have the solutions of n equals 7 and n equals 3. But let's go back to our problem. We need a little space. I'm going to go back to the rearranged version of our problem that was square root of 15 minus 2n equals n minus 6. I like to plug into that version better. I don't like working with extra negatives. So if n is 7, and I put a 7 right here, I get 7 minus 6, and over here I get square root of 15 minus 2 times 7 is 14. So that's square root of 1 equals 1. Yes, that works. But let's check the 3. 3 minus 6, is that equal to 15 minus 6? Well, this is square root of 9, and this is negative 3. Square root of 9 is not equal to negative 3. So this is what we call an extraneous solution. So I want you to cross it off and then write ext next to it. So this is a case where the quadratic produced 2 answers, but when I checked one of them, it didn't work. It happens. Oh, apparently that's all the examples I have for you. So we saw examples where quadratics, were produced. We ended up with 2 good solutions. We saw examples where quadratic produced 2 solutions, but one of them was not good. And I haven't given you any yet, but there are examples of these problems where you produce solutions and none of them work. So if that's the case, we say that there's no solution. So our next task, and what I'm going to ask you to do probably tomorrow, is kind of go through what it looks like when you graph these problems together, like we used to do back in the day, and then see how the intersection points can correlate to the 2 solutions, or the 1 solution, or the no solutions that we found. We're going to put a couple ideas together. So I feel like celebrating, guys. That was our last lesson. Congratulations, you finished the first semester of Algebra 2.